Okay, so I'm going to go over the classwork that went with the notes with a simple and compound probability. It's just the one page. I'm going to jump in here. In a stack are several number cards. There are 3 1s, 4 2s, 3 3s, 4. Okay, there's a lot of cards. You pick a card at random. All right, let's do this first. How many total cards we talking here? All right, we have 3 1s, 4 2s, 3 3s, 2 4s, 2 6s, 6 7s. All right, so how many total cards are we talking? 3 plus 4 plus 3 plus 2 plus 2 plus 6. I got 20 cards. Okay, so find the probability of pulling a card with the number 3 on it, and we want to find that probability as a fraction, a decimal, and a percent. So let's see here. We have 20 total cards. We have 3 cards that have the number 3 on it, so we have a 3 out of 20 chance of pulling this card, and that's our fraction. If you want to know the decimal, put that in your calculator. 3 divided by 20 is 0.15, and the percent, move that decimal place over twice, is 15%. All right, so what is the probability of not pulling a 7? All right, so we have 6 7s, and we have 14 other cards. So basically, we want to just, what is the probability of pulling any card that is not a 7? So we have 3 1s, 4 2s, 3 3s, 2 4s, and 2 6s. If we add up 3, 4, 3, 2, and 2, we get 14. So we have a 14 out of 20 chance of pulling a card that is not a 7. If you want to reduce that fraction, it goes to 7 over 10. The decimal that goes with this is 0.7 or 70%. Okay. Second question, Megan. She's got some M&Ms. She has 4 red, 6 blue, 3 yellow. Well, she got all these M&Ms. She puts the M&Ms in a cup and takes one out at a time and eats them. For parts B through D, we're going to start the problem over each time. So we're going to pretend like she's starting back with all of her original M&Ms. And we're going to find the probability basically that she picks an M&M and then picks the other one. But this is without replacement. But she's picking an M&M, she's eating it, and then she's picking another M&M. Before we get to these, let's talk about how many total M&Ms do we have. So we have 4 red, 6 blue, 3 yellow, 1 green, 4 orange, and 2 brown. If I add all these up, 4 plus 6 plus 3 plus 1, I think I get 20 again. We got 20 M&Ms. Okay, so now let's do the hard part. What is the probability that we pull a red M&M, eat it, and then pull a yellow M&M? All right, so the probability of pulling a red M&M is 4 out of 20. And then we're eating it. So how many M&Ms now do we have? Well, we don't have 20 M&Ms anymore. We now have 19. We are not replacing that M&M. This is that dependent events that we were talking about on the notes. So we only have 19 M&Ms left. How many of them are yellow? We have 3 yellow ones. And we want to multiply these two numbers together. So 4 over 20 times 3 over 19. We're going to get another ugly decimal of 0.0315. We'll say 0.032. If you convert it to a fraction right away, so don't convert this to a fraction, convert the number you get in the calculator to a fraction, this whole thing right here. If you do the math, frac, I get 3 over 95. And the percentage of this would be 3.2%. Moving that decimal place over 2 times. All right, what is the probability that we get 2 blues in a row? All right, we have 6 blue M&Ms, and we're starting the problem over. So we're going back to 20 M&Ms, all right? So we're pretending this is a alternate timeline where she's pulling 2 blues in a row to start with instead. So we have a 6 out of 20 chance of pulling a blue M&M. So what is our probability now of pulling that first blue M&M, eating it, and now pulling this second blue M&M? We only have 19 M&Ms left. And how many blue M&Ms do we have left? We already pulled one out. There are only 5 blue M&Ms left because we already pulled one out and ate it. So be careful with that. This is the first time we've seen one of these, but this number can also be reduced by 1 if you've already pulled it out. If we multiply these together, 6 over 20 times 5 over 19. I'm going to get something like this 0.0789. I'm going to round it to 0.079. If you convert it to a fraction right away in your calculator, you're going to get something like 3 over 38. And this right here becomes the percent, 7.8%. So all three of these are fine answers, decimal, fraction, percentage. All right, and then last one, what is the probability of pulling a green followed by a red? If you haven't tried this already on your own, I would really suggest you try this one on your own and see how you do. All right, I'm going to do it now. So the probability of green followed by a red. We have one green M&M. So we have a 1 out of 20 chance of pulling a green M&M. And then, you know, we're eating that green M&M, so we only have 19 left. And we have 4 red. We don't subtract this by 1 because we ate a green M&M. That has nothing to do with the reds. Multiply these together. And we get something like 0.0105 or 0.011. If you do the fraction right away in the calculator, you get 1 over 95. And the percentage for this would be 1.1%. Okay. That ends the classwork for our simple and compound probability. Make sure you go back to Canvas and fill out the digital evidence of learning for today as well. All right. Have a good day.